Seaborn's website looks like this. Seaborn is a Python module that's actually based on matplotlib, but it has some nice extra features. You can think of Seaborn like matplotlib on steroids. If matplotlib was Lance Armstrong, then Seaborn is still Lance Armstrong on the Tour de France. So let's import the Seaborn module at the top of the notebook as SNS. I'm going to write import Seaborn as SNS and hit Shift Enter. In the cell below the histogram, we're going to make use of one of Seaborn's functions. We're going to make use of the distplot function. So SNS dot distplot parentheses data square brackets single quotes price in all caps, and then enter plt dot show parentheses. Seaborn's distplot function only needs a single argument, namely the data it's meant to plot. And we're going to plot the target values, and we're going to see how this compares with matplotlib's histogram function. So let me hit Shift Enter. And here we can see that straight out of the box, we get a very beautiful graph. We get both a histogram and an estimate of the probability density function. The probability density function is the darker squiggly line that's superimposed on top of the histogram. This is the line that estimates the distribution of the data. And I think this is a neat little addition that Seaborn provides as an add-on to the histogram. Now, of course, we can make the Seaborn plot look a lot more like matplotlib. So for starters, I could size it differently. So I'm going to take this line of code here, copy it, go down here, paste it, press Shift Enter. You can see that it's a bit larger, a bit easier to see. But we can also modify the number of arguments this plot here takes. So it also has the bins argument that we can give it, and I can give it 50. So now this ties out with what we see up here from matplotlib. And then we can also show and hide the 2 bits of the graph here, the PDF or probability density function and the histogram. So if I come up here to the arguments and I put hist equals false with a capital F and hit Shift Enter, it hides the histogram and we're just left with the probability density function, which is the estimate for the distribution. And of course, we can also do it the other way around. So if I write KDE equals false, and then change the hist argument to true, then we're hiding the probability density function and just showing the histogram. And in terms of styling, you can also grab a different color here. So if I want to go with a yellow palette, for example, pick this hex code, go back here, and then add the color argument as a keyword, and paste the hex code in, hit Shift Enter, and then we'll see it like so. Now, in retrospect, I don't think this was actually a wise choice. This is very, very low contrast. I might have to go for something like this, which is a bit more amber, and substitute that for the yellow. And this makes the histogram a lot more clear. All right, so I think this is a really good time for a challenge. See if you can investigate and visualize 2 other features of the dataset. And I also have a question for you. How many rooms do you think that the average property in Boston has? What do you think? What's the total number of rooms for a property in Boston? So including bedrooms, living rooms, bathrooms, etc. Have you made your guess? Okay, so for this challenge, we're going to be checking the answer. We're going to have a look at the RM feature. Can you write the Python code to plot this on a histogram and visualize the number of rooms per dwelling, and then figure out what the average number of rooms is for a property in Boston, Massachusetts? I think this should be fairly straightforward. You can use either matplotlib or Seaborn to generate your histogram, but maybe have a think about what you would expect beforehand. Ready? Here's the solution. So what I'm going to do is I'm going to take this cell here. I'm going to copy the cell, come down here and edit, paste the cell. And then what I'm going to do is I'm going to change the code here. So I'm going to substitute RM for price. I'm going to delete the bins. I think this is no longer what we want. I'm also going to pick a different color. So maybe I'm going to go for teal. Maybe this dark teal here, just to differentiate the chart a little bit. And then I'm going to change the X label here because we're no longer looking at the price. We're looking at the number of rooms. In fact, this is the average number of rooms. And now I'm going to hit Shift Enter. And the chart that I get back looks like this. We can see that the highest bar is around the number 6. In other words, most of the properties in Boston have around 6 rooms. Now, I don't know about you, but that actually seems pretty big, actually. Because if you think about it, bedroom, living room, kitchen, bathroom, that adds up to 4. If you add another bedroom, then you have 5. But the average is 6. So either they have a linen closet that they're counting, or they have 2 bathrooms or 3 bedrooms. Now, of course, we don't know anything about the size of the rooms, but still, I'm going to venture a guess that 6 rooms on average doesn't seem to be too shabby. I certainly wouldn't mind living somewhere with 6 rooms. That's palatial by London standards. Now, we just eyeballed this graph to figure out the average number of rooms. What if we wanted to know an exact number for the average? Well, Pandas also has you covered for that. So what we can do is come down here and access our RM data series. So data, square brackets, and then RM. Put a dot after it, and then call the mean function. So data, square brackets, RM dot mean, parentheses. So here we're calling the mean method on our series object. And hitting Shift Enter, we see that the true average is 6.28.